In this video, we are going to look at a polynomial in factored form. Let p of x be a polynomial of degree 4, with roots -2, 3, and 2 plus I, and suppose p of 0 equals 10. First of all, notice that our polynomial is of degree 4, but we're only given 3 roots. That is because the root 2 plus I is complex, and thus will have a complex conjugate pair with it. Thus, we can write p of x equals a times x plus 2 times x minus 3 times the pair x minus 2 plus I times x minus 2 minus I. Now we want to find out what a equals. So, knowing that p of 0 equals 10, first plug in 0 for x in p of x. So, p of 0 equals a times 2 times -3 times -2 minus I times -2 plus I. Now from here, we can look at these last two factors and multiply them out. So, we get -6a times 4 minus 2i plus 2i minus I squared. Then -6a times 4 plus 1 equals -6a times 5, which equals -30a. But we also know that p of 0 equals 10. So 10 must equal -30a. So solving for a, we get a equals -1/3. We can now write our polynomial in two ways. The first is just taking what we solved for a and putting it in the way that we've been writing the polynomial up to this point. So p of x equals -1/3 times x plus 2 times x minus 3 times x minus 2 minus I times x minus 2 plus I. This form has linear factors with complex coefficients. That is because each x is to the first power, and these last two are complex. To get the next form, we'll take these last two factors and multiply them out. So, p of x equals -1/3 times x plus 2 times x minus 3 times x squared minus 4x plus 5. Now p of x is in its irreducible quadratic form. That is because this last factor is quadratic, but we can't reduce it any further without getting complex roots.